Greetings and welcome, friends. Mr. Waddy here. Today we are talking about inscribed angles and polygons. It's going to be great. 10.4. Here's some vocabulario for you. It says an inscribed angle is an angle whose vertex is on the circle. The vertex being right here, like so. The vertex is on the circle, Haley and Lauren, right? And whose sides contain chords of the circle. Right, so you can see that AB is a chord and BC is a chord. So angle ABC is an inscribed angle. An arc that lies between two lines, rays, or segments is called an intercepted arc, and an inscribed angle can obviously intercept an arc, okay? And then that arc also has its related chord there. So there's a relationship between all of these things, right? We've seen that before. And also in a moment, we'll talk about central angles. What is a central angle? Do you guys remember? A central angle is going to have a vertex at the center. And so a central angle will have sides that are radii of the circle. Okay? And we've talked about the fact that the measure of a central angle is the same as an intercepted arc. All right, here's this crazy thing. It says, if the endpoints of a chord or arc lie on the sides of an inscribed angle, all right, so if the endpoints of a chord, like AC, or the endpoints of the arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. So subtending the angle would be to, right, basically connect 2 points on the angle. All right. Now check this out. We just did some geometer sketchpad of this, and we found out that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So its intercepted arc would be this here, and the intercepted arc also has the same angle measure as the central angle that intercepts that arc. So angle ACB has the same measure as arc AB, and both of those are twice as large as angle ADB. Right? Right. So these are going to end up having lots of properties that end up applying. Let's look at example 1. Most of these, fortunately, are pretty easy to implement. All right, Isaiah. That's enough. That's enough. You're like bottle flipping with a shoe? So let's see, example 1. Using inscribed angles, find the indicated measure. All right, so find the measure of angle T. Angle T is an inscribed angle or a central angle? Which is it? Inscribed because, Ty, why is that an inscribed angle? The vertex is on the circle. Let's see, Aiden of Diamonds, which arc does angle RTS intercept? Intercept. Which arc does RTS intercept? For the arc? Arc RS. And arc RS is 48 degrees. So, Katie, what do you think? How could I find the measure of this angle with respect to that arc? Yeah, so it's 1/2, so 24 degrees. All right, here, then we've got, let's see, Lauren, see if you can help us out. QR. Oh, man. Oh, dear. Oh, dear, guys. Uh-oh. How are we even going to find this one? This is craziness. Find all of the other ones? All right, it's looking for arc QR. I'll do this in a different color. All right, so arc QR. Now, someone help me out. Is arc QR intercepted by this 50-degree angle? No. The arc that's intercepted by the 50-degree angle is QT. And if this is 50, what is arc QT going to be? 100. All right. What is arc ST going to measure? This is a diameter. What is the angle of this diameter? 180. And therefore this arc is 180. 180 minus 48. Well done, Joshua. I believe is 132? Yeah. And therefore, if I want to find arc QR, that should equal how many degrees are in a full circle? 360 minus the 100 plus the 132. Isaiah, that's enough. And the 48. So this was 180. That's 280. Subtracting that looks like 80 degrees. You guys agree? So 80 degrees is this. Now question, bonus round. Ready? Part C. What if I want to find the measure of angle QTS? Think about that for a minute silently and see if you can come up with it. I'll walk around. It is not currently. I was originally arc. Does anyone agree or disagree? Right, let's find out. Okay, so internet friends, I actually labeled the one I did not mean here. So this one that I'm referring to, so Q to the T, all right, is this, and to the S is that. Now, there we had an arc addition postulate that said that the entire arc is equal to the sum of its non-overlapping parts. So this entire arc is 80 plus 48, which is 128 degrees. And Isaiah, what does that mean for angle QTS? I'm taking it. All right. And that is an inscribed angle. How about QTR? With 40, right? It's half of the 80. Well done. Well done. Well done. All right, cool. Let's keep going. Example 2. Man, I like those last couple questions. This is good. All right, finding the measure of an intercepted arc. All right. All right, it looks like SUR is the 31-degree angle. It intercepts this arc SR here. So what is arc SR going to be? Doubled is 62. And, gentlemen, what does that mean for this arc here, STR? That's going to be 31 degrees. Why do you think that's true? Because they both intercept the same arc. Isn't that craziness? Right? They both intersect this, intercept it, intercepted. And therefore, they are both half the measure of that arc. And so they're 31 degrees. All right? All right. Let's keep going. And that's going to be a theorem, my friend. I said my friend singular. You know who you are. All right, so the inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then their angles are congruent. All right, Isaiah, which arc are angles D and C intercepting? Which arc? Right, arc AB. And if they're both half the measure of AB, they are equal to each other. Right? So that's not that bad. Yeah. Okay, so here's angle D, right? It hits here, and it hits here, and then if I imagine the arc that is in between those two. All right? Yeah. All right, how about example trace? Right, these are not too difficult, I don't think. But I think these are some elegant problems that I would not have expected this. All right, I don't know. I mean, you've probably never thought about intercepted arcs and inscribed angles, but I would not have expected this. This isn't something that I was thinking about. All right, finding the measure of an angle. Given angle E is 75 degrees. Why do you say that? Justify it. Which arc? GH. And because they intercept the same arc, they're both 75 degrees. I'm telling you about it. All right. Ooh. Interesting. Ooh, I can't wait. Like, we are on the threshold of an interesting concept that I don't think... Oh, no. All right, good. It's after this one. Okay, so we talked about this. Some of us did get to explore this idea in Geometer Sketchpad. A polygon is inscribed when all of its vertices lie in a circle. All right? The circle that contains the vertices is a circumscribed circle. Okay? So that's what an inscribed polygon looks like. Ooh, I think I might have given us false information earlier. All right, each of these angles is going to be an inscribed angle and is half the measure of its intercepted arc, right? But the problem is that this angle intercepts a part of that arc. There's overlap. All right, so that's going to be interesting. Okay, that's going to be interesting. Now, when it comes to triangles that are inscribed, this, I think, is such an interesting outcome. An inscribed right triangle. Can someone explain to me why is it, if I inscribe a right triangle, that it has to intercept with a diameter? All right, if this is a 90-degree angle, that means the arc that it intercepts is 180 degrees, and the chord that connects the endpoints of that arc is going to be a diameter. So that means any diameter, okay, if you imagine, well done, yes. If you imagine any point on a circle and then connecting that to the diameter, all of those points will be forming 90-degree angles, which I think is an interesting relationship between right triangles and circles, and it will not be the last relationship that you see between right triangles and circles. All right, and then you can also inscribe a quadrilateral, and this is the one that my theory was wrong when we were talking earlier, just thinking about this stuff. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. All right, so angle E intercepts an arc. Angle G intercepts another arc. One of those arcs will be a major arc. One will be a minor arc. And what do I know about both of those arcs? Here is E's intercepted arc. Okay? Here is angle G's intercepted arc. What do you know about those two arcs? If this was a diameter, then yes, those would be semicircles. We're not assuming that it is a diameter. I'm just saying, like, any two, these two, because they intercept the same points. This arc, what is orange arc plus purple arc equal to? 360. E is half of the orange arc. G is half of the purple arc. So therefore, together, they are going to add to 180. They will be supplemental to one another. Okay? All right. Let's see. This might be... I think this is our last example, because example 5 I thought was just kind of like, meh. I wasn't that impressed with it. It's like about the Statue of Liberty and taking a picture. All right, find the value of each variable. Okay, let's see. Malik, I drew your card. Let's look at this. Find the value of x in part A. Malik, what are you thinking here? Or tell me something you know about this so far. How do you know that? So because this is a diameter of the circle, then it's the hypotenuse of a right triangle. And then what's a quick equation you could tell me about 2x? Right, and then divide both sides and you get 45 degrees. Right, well done. Let's see, Aiden Murphy, trickier here. Oh dear, let's have you find y for us, Aiden. So here's a quadrilateral, inscribed. Isaiah, you can sit down. Inside of a polygon, circle, there we go. What can you tell me about those two angles, Aiden? Yep. Yep. Yeah, I like it. Let's see. And let's have Lily, if you could. Could you help us figure out angle Z? Or write an equation for us? Yeah. Hundo. I like it. All right. Well, thanks for watching, internet friends. Have a great day. Bye-bye.